welcome to the first video on how to use NeuTrace 2.0. My name is Joy Franco, and I developed this macro. It's been a work in progress for a few years now. I started it in my dissertation research with Miriam Goodman at Stanford, and now I'm keeping it alive and adapting it as necessary for other purposes. So I'm going to walk you through how to use the code and what to expect from it. So first thing is that you need to have ImageJ installed on your computer. It doesn't matter if you have the Fiji version. Actually, maybe it does matter if you have Fiji. It probably does. The main thing is you need bioformats. So most installs of Fiji should be just perfect. So you have ImageJ open, and you're going to go, you need to open the macro file. So to do that, you can go to Plugins, Macros, Edit, and then you need to locate the ImageJ file. So NeuTrace2.0 ImageJ. We're going to open that. That's going to open the ImageJ development environment, which is where you write code. And you don't need to worry about anything that's actually in the code. Just don't touch it, don't edit it, don't save over it. But if you do want to try to understand what it does, I tried to add comments, and I will always continue to add more comments to the code to make it more user-friendly, because the whole goal of me sharing these macros is so that you can start to learn how to use ImageJ and tweak it so that you can optimize and expedite your own image processing. It's a really powerful package, and I hope more people start to use it this way. Okay, so you have NeuTrace 2.0 open, and all you have to do is, so at this stage, all you have to do is hit run to get the macro going. So we hit run, and you'll notice a few things popped up. So notice that the ROI manager popped up and that a log popped up. Just ignore the log. This is for internal purposes to get a timestamp. So there's this welcome screen that I wrote to make sure that you know that the command is running, because sometimes ImageJ doesn't show this running command. And so it explains that this macro will open your .nd2 file of choice and guide you through the neurite tracing process. When presented with the bioformats opener, make sure split channels is not checked. Click OK when you're ready to proceed. So then the next window you see is, it's just kind of a generic screen. It doesn't really tell you what to do. That's why that welcome screen has the instructions, so that you know what you need to do is go to your data file, go to where your data is stored, and there should be a folder called raw images, and it needs to have all of your raw .nd2 files. This is very important, that all of your raw .nd2 files are stored in a folder called raw images. Then you're going to select that folder, or sorry, select that image, whatever image you want to analyze. Open it. Now this is the bioformats import options. This is bioformats importer. So these are all default settings, so you shouldn't have to adjust anything here, but under split into separate windows, sometimes split channels is checked. You want to make sure it's unchecked. Click OK. All right, and then you're going to start to see a bunch of actions, so just try not to touch anything until you're actually instructed to. So here it's saying action is required. You want to examine the Z-stack and choose which images to include in the max projection. Sorry for the typo. You will enter the specifications in the next dialog box. So while this dialog box is open, you can actually move through the stack and say which slices do you want to include. So, you know, for your purposes, you want to avoid highly saturated images, and you want to try to only include those that have low saturation. So let's just say slices, 6 through 10. All right, so we're going to remember those. Just keep them in your head. The macro will store them for you, but you need to keep them in your head right now because you're going to enter them on the next screen. So you click OK, and now create substack. So now here you're going to enter which ones to include. You'll notice that ImageJ is a little bit buggy with this window because I'm trying to click slice start and nothing's happening. And then I try to delete the one and it says this command requires a selection. This happens a lot, so just click OK, and now you can enter, let's say, slice start from 5 to 10, and then we want both channels 2 and 3. Click OK. All right, so it made a substack and it made a max projection. So now the next action required is to select the segmented line tool by right-clicking over the polyline icon in the toolbar. So this is the polyline icon. Sometimes when you open ImageJ, it just looks like this. Sometimes it might look like this. So that's why you're going to right-click over the icon and select segmented line. Then, as it says in the action required box, once selected, double-click the same icon and check the spline fit box. So you're going to double-click that, and this new window pops up, and it says line width 8. Leave it at 8, and then click, or if it's not at 8, make it say 8. Then click spline fit, and you'll notice that unfortunately, again, this is an ImageJ bug where it doesn't show you the check no matter how many times you click it. So what you have to do is just wait in a second and I'll explain that. So in the ROI Manager window, select Show All and Labels. Okay, Show All, Labels. And then after this, you're going to begin tracing and adding them to the ROI Manager. So we did everything that it told us to do, so we're going to click OK. Now it's saying another action is required. Trace a neurite, then press T to add it to the ROI Manager. Trace as many neurites as necessary, then click OK to save each. Don't click OK until you've traced as many neurites as necessary. So you're going to go in and you're going to start tracing. Okay, and you can see that that's what I'm doing here. I'm clicking T to add it to the ROI Manager. Then let's say I actually want to get a better view. I'm going to zoom in, which is something you can do here, and then you can actually trace more finely. Okay, press T to add it to the thing. Now, going back to that whole spline fit issue, do you see how each line it's very like stiff? They're not curved. It's just like a straight line connected to a straight line. Spline fit is what gives a better approximation of the actual neuron morphology. So we want to make sure that's checked. So you can see from that bug earlier, we couldn't check it earlier, but once we've actually gone in and traced something, like we do here, then we can make sure it's checked. And you can tell the difference, right? Because it's curvy. Great. Okay, so we made 3 neurite traces. Mine are very short, yours can be longer. If you need to move through the image once you're zoomed in, you can do that using the pan tool or the scrolling tool. That's what the hand is called. And the hand will let you move through your image. So you're like, oh, I see this one. This one looks really good. I want to trace that. You have to go back in and reselect your segmented line tool, and then you can trace that one. Okay, so now we have 4 traces. Okay, so now that we have all of the traces that we want for this image, we're gonna go and we're gonna click OK. And a bunch of stuff is gonna happen, and you're gonna see that and you're like, what is happening? So that's the macro actually going through for each ROI, for each neurite trace, and processing it the way that it's supposed to. And I'm gonna walk you through what it produces, but let's finish the macro first. So here we get another action required box, and it tells us to take a screenshot of the max projection with all ROIs shown, then click OK to exit. So this is mostly because when you do this type of image analysis, people really want to see where did you trace. And the easiest way to show them is to just show them the max projection images with the ROI selected. And the way that you do that is unfortunately a little bit manual, but that's okay. So you have your max projections for each channel, right? This is channel 2, this is channel 1. Arrange them on your screen however you want. Maybe you want them this way, the other way, because channel 1, channel 2, left to right. Click on the channel 1 window, click and unclick show all. Now you can see 1, 2, 4, 3 is somewhere. There it is, number 3. Okay. Click on the next max projection, click and unclick show all, and now they appear. 1, 2, 3, 4. If you want to get really fancy, what you can do is go into properties and say, okay, I want that first ROI to actually be red, because that'll help you see it better, and click OK. And now, oh, sorry, that's the group. There is a way to change just the color of one of them, but either way, it's having them all in red is fine. That looks great. And then you can apply the same idea here. Okay, so to take a screenshot, if you're on Windows, you'll use the snippet tool. If you're on a Mac, you'll use the screenshot tool. And then, you click capture, okay, done. You save that. You're gonna have to manually save that in your folder. And then you click OK to exit. Boom. All right. So what did NeuTrace produce for us? The first thing is to see that is we're going to go into our data folder where the raw images folder is saved. We see there's this new folder called NeuTrace results. And in NeuTrace results, there are 6 subdirectories. The first one is the neurites. These are the straightened neurite views for each ROI that we made. And we can see that they're saved based using the image name. So this is the image name. This is the image that we analyzed. This is the neurite ID, just neurite 0, just neurite 1, just neurite 2, just neurite 3, because we had 4 ROIs and the system uses 0 indexing. So the first one is index 0. Second one is index 1. We can talk about 0 indexing in another video. And then the second extension is channel 1 versus channel 2. So channel 1 and then channel 2. Don't be alarmed if it just looks like a white box. That's because most operating systems struggle with TIFFs. But when you open it in ImageJ, you'll see it's actually like, oh, that's the straightened neurite view. And you can tell that I didn't do a great job of tracing, because instead of having the neurite only in the center, my line kind of went off center. All right, so closing that. All right, so that was just to show you that what these look like, right? There you go. Then the max projection is the max projection of the substack. And again, it doesn't look great there, but when you open it, you're like, oh, okay, this is the maximum projection of channel 1 and channel 2, okay? Then the metadata is a CSV file that you can open with Excel. And what you see is that for each ROI that we generated, each trace that we made, it saves the image name, what image it came from, the timestamp, what time you did the analysis. And then this is the substack that you generated. So you told it to start with slice number 5 and end with slice number 10. This is the neurite ID, right? So neurite 0, 1, 2, 3. And then this is the actual length. So this is how long the trace was. And then some of this doesn't matter right now. It's just saved because it's easy to do that. But I also added the mean gray value. So the pixels along that length, the mean gray value in channel 1 are these values, and then the mean gray values in channel 2 are these values. You don't have to worry about this right now. This will be used in the Python code Axon Analyzer. Okay, so close the metadata file. For these CSV files, just don't edit them. So don't resave them. Just if you open it, don't change anything, and then don't save. And sorry, that's Windows. Okay. So, all right. So then what else did NeuTrace make? So it made plots, right? So this is just, this is just for your own quality controls. You can go in and see what plots did it generate. And I just noticed that there is an error here because it's saving over. So I'm going to fix this. But in the I don't want to have to redo this entire video. So I'll just tell you that I'm going to fix it. And in the future, what you'll see is one of these plots for every ROI that you make, for every neurite trace that you make. And this is just for quality control so that you can manually go in and see what they look like. Okay, the ROIs, this is the zip folder that you can reopen using ROI Manager. So you might be able to click and drag. No, okay, so we go into ROI Manager. If you want to see what they are, let's just delete all of these so that I can prove to you. When you get those errors, just ignore them. Okay, so more, open the ROI zip folder. And you see, oh, look, there they are. And you can actually apply those to any image. Like, it's not specific to the Z stack or whatever. But let's say you're talking to your mentor and you want to show them what you traced. You can open up the max projection image, and then you can go boom, 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 done. All right, almost done. Substacks. So this is the last thing that NeuTrace produces. It just saves the substack. So you told it to only include channels, at the time they were called channels 2 and 3, and slices 5 through 10. And so it created a new substack to show that. Notice that it saves it with the high-low lookup table. I don't love that, but I couldn't get it to save it with gray. It doesn't matter though, because what you can just do is go back and manually change it to grays, and then save it again if you care about that, and just replace it. That's fine. All right, so that's NeuTrace 2.0. My name's Joy Franco. Thank you for joining me today, and please definitely feel free to reach out to me over Twitter or Instagram or whatever, or GitHub, if you have any troubles with this, and I'll try to keep working on it and updating it in my quote-unquote free time. All right, thanks.